Hey everyone, today is day five. Day five. Oh, got a whole hand here. Day five of algorithms in Swift. Today we're going to be doing an easy problem. It's going to involve strings. It's going to be the palindrome problem. A palindrome is a word that is read the same spelled forward as it is backwards. So wow is a palindrome, or level is a palindrome, or Anna is a palindrome, or LOL. You get the picture. So we're going to go straight into it. So let's go. It says create a function that accepts a string and detects whether the string is a palindrome, ignoring case. If you can solve this without using a library call, you can consider this problem tricky. Test cases, the string rotator should return true. The string level should return true. The string rats live on no evil stars should return true, because all these examples spelled backwards are spelled the same way forward. But something like this, like never, would not be a palindrome because it does not return the same way backwards. So you guys get the point of palindromes. And if you don't, look more into it on the internet, do some more research. So what we can do here is we can actually solve this problem rather easily with a library call. I'm going to show you a very easy way to solve this problem, and then I'm going to try to do it the tricky way. Okay, so we can solve the problem rather easily with a library call. In fact, we probably solve it in one line of code. In fact, we will solve it in one line of code. Rather confident about that. Return string dot lowercase. Since we're ignoring case, let me just reverse the entire thing and then ask if it's equal to the string that's passed in. So believe it or not, that is all that's needed to solve this problem. So if we put rotator here, in fact, no, I think I'm going to be extra careful, because when you reverse a string, it becomes a reverse collection type, reverse string collection type. So we want to make sure that it is always equal to string, so we don't have any weird behavior. But this should return true. In a second. Yep. And then level should return true as well. True, okay. And then never should also return true as well. Well, never should return false. Yep, okay. So we have this problem correct. Okay, so this is a fancy one-liner you can use. It uses a library call. Now, I want to show you a trickier way to solve I want to, pass the tricky tests of this problem and help you solve this in a more unconventional way. So instead of, doing the reverse library call, you could just create another string and make it equal to the string that we have here. And then we just could for loop through it. And what we could do is every time we get a letter, we could, for every time we pass over a letter, we could insert that letter at the beginning of the string and chop off the end of chop off the last letter of the string. So we're inserting the letter at the beginning index and chopping off the last letter of the string every single time. And every time we insert a new letter in, the letters adjacent to it get pushed further down the line in the string. So essentially, we are reversing it in real time. Okay. So I'm going to print it out for you guys to get a visual of what I'm talking about. But trust me, it works. So reversed string, insert letter at reversed string, start index. Okay. And reversed string that remove last. Also, Swift treats remove last and remove at end index differently. I'm not sure why it treats them differently, but it treats them differently. So be aware of that. Okay. insert, oh, sorry, insert, letter at reversed during the start index. Okay, and then it's basically gonna ask if reverse string is equal to the regular string after we reverse it. That lowercase is equal to string. Okay. So if this is true, let's do level. Level should return true, and never should return false. Oh, sorry. In fact, let's make this lowercase. So we do it for capital letters. Okay, let's do rats live on no equal star. That should return true if we're fine. Okay, and then never should return false. Okay, so and I'm gonna let you guys see this in real time, so you see exactly what I'm doing. So let me actually put an invalid palindrome. Let's do rats live on no equal star. Okay, so right here you see, trying to make it bigger. You see right here, we're taking the first index. It's almost the string. But the for loop by nature makes a copy of the letter. Okay, so we can take advantage of that in Swift. It makes a copy of whatever index is iterated over. So we take a copy of the R that's indexed over, insert that in the beginning of the string, then we chop off the end of the string and chop off the R. Okay, and what you can see here essentially is that even the second round, the next letter is A in rats. So A gets put inserted. A copy of A gets inserted into the first index of the string, and the A that's on the last index of the string gets chopped off. So essentially, we're just pushing down the letters in reverse down the string. Okay, then this is what I was talking about how every time you insert a string, the strings adjacent to it get pushed down further. So the R that was at zeroth index gets pushed to the first index, and the A becomes zero index. Now the A is zero index. We have T now. We're on a T now. So T becomes zero index. A becomes 1. The capital R becomes 2, and the T is now gone from the end of this palindrome, and all the way, and it keeps going down and keeps reversing all the way until you have a reverse of the entire sentence. Rats live on no equal star. Okay, and then just because some palindromes may be uppercase or lowercase, to get rid of casing because we're ignoring case, we just lowercase both strings, reverse string and the string that came in, and ask if they're equal to each other, and that gives us a palindrome. Rats live on no equal star. So this is a clever way to solve this. This could be computationally expensive because you're constantly inserting and removing out of an array or out of a string. That could be computationally expensive depending on how long the string is. So you could get a debate about that, but I think this is a custom way to reverse strings in real time, and I think this is a much better and swiftier and clever way to solve this problem using just your knowledge of how for loops work and how reversing strings and using indexes can work in Swift. So thank you for your time, guys. Hopefully you found this useful. Please like, comment any solutions that you have, and share the content with you or anybody else that's looking for a job interview or is currently interviewing for a job. Thanks again. Bye.